Okay, welcome back. Lecture 9, Network Programming. It is cold in this room, you're right. It's freezing. Continuing right along with more topics. We're slipping right in. This is a very short lecture, so we'll do this and then we'll have lunch. So, the URL. We already know what that is, hopefully, for engineering students. It's a unified, an acronym for Unified Resource Locator. It's a reference to an address, an internet address on the internet. Actually quite simple in terms of how we program this in Java. We can create a sample structure for URL in terms of a resource, in terms of the name, and it contains host name, file name, port number, reference optional. So here's a URL. Where everybody knows about URL, so I can kind of breeze through this. java.sun.com. So you can create a URL object in Java from an absolute URL or a relative URL. Any URL works, essentially, for the object. So the URL class provides several different methods to implement on a URL object. So you can get the protocol, host name, port number, file name from the URL. So essentially what we're looking at is looking at the Java I/O Java net here. So I/O is going to give us the input-output on files, stuff like that nature. Net is the import class that we're going to use, java.net, to work with, and the URL is a concept. So we create an object for a URL, and then we can parse the object to get the host, the file, whatever it is we happen to want to be able to use that for. Great for going to websites and getting downloaded material, getting files, getting information, content. And one of the examples I just showed you, and we'll go back to it and visit it and look at the URL object. It actually takes the URL and actually just goes to it, finds and retrieves the document, essentially. And the document is an HTML document. So I could write that, or change the code a little bit to go to the website and save the file on my computer, or open it up in a web browser, or create a web browser, essentially, which isn't too hard, actually. I just have to display HTML content instead of displaying text content. So here we have an argument that throws a URL new. So URL, a URL is going to be equal to a new URL, and here is the URL. And so we have a system out protocol. It's equal to this, and here are the objects. Excuse me, the methods that we're running on the object. We're getting a protocol, which is essentially getting the host, get the host, get a file, get a port, get a reference. And the output of the following that we're printing out to the screen is going to be the protocol's HTTP protocol. So we can do FTP, HTTP, I don't know, wget, you can use a file transfer port. The host is what we've supplied in here. So what this is doing, the methods are dissecting the URL out into the small different components and treating them as the separate components. The file name, the port that we're using is 80. The reference is going to be downloading, which is the name of the file. Reference, we gave it at the end of the name of the file. So it's helpful when using internet to connect to perform operations, transfer files and stuff. So OpenStream returns the Java I/O input stream, as we saw last time in another lecture on I/O. And we create an object that you can read easily by reading in the input stream. And it can also throw an exception. So we can read the URL, open the stream using the same kind of format that we did with opening a file, and we just read in the items, which is what that example is doing, and I'll show you in a few minutes. So it prints out the source file of the web page, and this is printing out itu.edu because it's going to this website, this URL, doing a buffer reader in, reading in the I/O stream, creating an input stream from this, and just essentially printing it out on the screen. This is what the example that I'm going to show you that's part of that other text editor program is doing. So it's not converting anything to HTML, it's not working with it, it's just working with from a text perspective, from a file input stream, actually using the buffer reader.
Is to store and manual notation?
This is creating an object that is holding the information as a buffer, actually, of what was in the file or what was in the URL at the location. So it's not, what did you call it, a file? No. It's not a
It's a memory location.
it's not a memory location per se. It is actually, if you think about it in terms of how Java works, it is a reference to a memory location. You're right. Temporary memory location. Yeah, that's essentially the concept.
Input stream and open stream. What is object does?
OpenStream creates the file pointer to the stream, and the input reads it, takes and creates it. The buffered input, the buffer reader is going to create a buffer out of it. The input's just going to read it, process it, but not save it. Because you might want to read it in and then not have to go read it in again. If it's buffered, it's already located for you. You just copy the buffer to a string if you wanted to, if that were the case. To perform the networking operation, we open a connection. Returns a URL connection object, or represents a connection to the remote object referred to in the URL, and it will also throw an IO exception. So we go to http://www.itu.edu. It's a new URL that we're going to connect, and we're going to use a URL connection object to connect to this particular URL that we've created. The URL is going to be, I should have changed OSU, Oregon State University, to ITU, but essentially that's what that abbreviation is for. The URL connection class provides many of the methods to communicate to the URL, such as reading and writing to the URL. Normally, we're doing this if we were creating a web browser, and we would have to actually format the URL information, the text that we were getting, to display it somehow in a HTML compatible, if we're looking at an HTML document. We can do this to retrieve text files that are stored somewhere else without actually displaying them. So we could essentially go to a URL location on our website, open a text file that's storing parameter information, maybe, or storing information that we want to use, read the file, bring it in, and process it somehow, or use it somehow in our application. We don't need to use it for HTML or for web browser behavior. You can use it for anything, essentially. Great way for storing files on a server, opening up the files on the server, processing them, using them through a connection. Or having an application that goes to a server, opens up a file, uses it. And the file might keep maybe updated information on a project status, or maybe keeping order information or something. Much more than just web browsing. Document retrieval. Sockets. This is almost the same concept as you get in C or C++. Sometimes you need low-level network communications, such as client-server communication that doesn't work with, let's say, HTTP or opening up a connection for a URL. TCP, Transport Protocol, is a protocol for reliable point-to-point communication, channel via socket. On sockets, you can go UDP or TCP, whether or not you're going to work with it's all over IP, but one of them gives you connection and the other one gives you connection-less. So you can connection-oriented is the TCP, the connection-less is the UDP. TCP provides you constant one-to-one communication back and forth in a client-server model. UDP is great for applications where you just want to send a file, send some information, and then close the connection, and then receive something back so you don't have a constant connection going on. And the socket abstraction is something that you would learn about if you were to take an enterprise edition or a networking programming course in Java. It doesn't really follow through the object-oriented concept. However, we're showing this to you just to kind of complete a background in terms of what kind of objects you can create. A socket is an endpoint by abstraction for reliable communication between two machines. To connect each machine to the other, create a socket on the client, you create a socket on the server, socket objects, and you connect the objects and let one know about the other. So the net package provides two abstractions, socket and server socket, to implement the client and the server respectively. So you have a server socket that sits and waits for an opening, or a socket that looks for a server socket. So you can establish a simple server here in 5 different steps. You create a server socket object. So server socket server is equal to new. So you have to create that first, actually, because you need a server in order for a socket to connect to it. The server listens to 4 blocks attempting to do a client connection. So socket connection server.attempt is a method to run on the server object to say, hey, establish a connection with the client, or allow clients to connect to you. And then we get a new output stream or input stream object that enables the server to communicate with the client sending and receiving bytes. So the stream concept is kind of fundamental to file transporting from one location to another, getting from URL information, and also from socket communications. So the stream concept just takes and accepts information or writes information, depending upon, sends and receives essentially through streams. So you can get a stream on the other data using the input stream or the output stream, and then you process the information. The server and the client communicate with the input, the output stream object, and you copy the stream to something or use the stream for something in terms of the functionality. So after the communication completes, you invoke a close on the socket, and you close the streams. Essentially, you close the client, you close the server. In terms of a simple client, this is the example. In fact, you can do this you find simple client, simple server, Java, socket, some little mini applications all over the place. Usually a server loads up, sits there, you load up the client, you send hello world to the server. Server receives it and says, hey, I got hello world. It's using a stream, input stream. Prints it to the screen, goes away. Client comes back and says, hey, server got my message. Okay, bye. Simple little things to show that you can communicate. And you don't have to program in this for this particular course. There's 4 steps. You create a socket object, so socket connection, it's a new socket with a server address and a port that you're going to use. And you get output stream, input stream of the socket, and translate. So the server and the client can send and receive data back and forth in the same format. And then you have a processing phase in which you receive something. So the server and the client communicate via this input stream and the output stream object. You receive something, you save it, you process it, you do something with it, and then you close the connection and everything is done. So it's kind of a simple format. And here's some server-side code, and I've got some client-side code as well that you can kind of cut and paste. This is just like a hello world server program. Server loads up, receives messages, and prints the messages out that the client has sent, essentially. And you can kind of go through and kind of see that all client-server programs run through the same identical process. Server loads up, sits there and waits and accepts new input. And when it receives input, it processes the input and then it closes, or it stays open and waits for another client to open up and to use it. I'm not going to bother running through the example because we don't actually have to program with this for any of the assignments for the course. But it is interesting to kind of, be able to have something to look at. So you can create this by cutting and pasting these two, the server side and the client side. It's 2 different objects. And in a DOS environment, you load up 2 DOS windows, run the server in one first, load up another DOS window, go to command.com, open up another window. You invoke or initialize, make an instance of the client object. So you have 2 running programs in 2 separate DOS windows, and then send some information from the client to the server. And the server will receive it and print it to the screen, essentially in this example. Not doing anything too sophisticated. So here's a simple client-server pair example. And we have what happens on the screen if you run the code. First you run the server, then you run the client, and you talk. And this is a command prompt window, actually. This is a DOS prompt window. This is not a GUI application. So, and if it's not a DOS prompt, it's a terminal prompt window on a Mac system. Will simulate the same environment. But you actually have to open up 2 terminal prompts. What port number you use doesn't really matter. In fact, in most cases, you can assign, which is an automatic, just a random port to assign to use for the socket. The port abstraction, we have unlimited amounts of ports these days in terms of the abstraction. Some people like to hard set it. They go, port number 777 or something. And then, what happens if port number 777 is busy for some random reason? So you just automatically assign it a port, increment the number. You never run out of ports. So when you run it, this is kind of the correlating information that goes on. You can download the example and run through it yourself, actually, if you want to see it work. It should work. The only problem that you might run into is some computers with firewalls that block the ports. If that's the case, you might have to disable your firewall or your security software if you're running anything that is going to protect any of the ports. Same thing that instant messaging programs generally have to do. Usually have to disable some ports or disable some protection. Concept of the datagram is what we get with UDP. So TCP is controlled, connection-oriented protocols. If you remember the OSI model and internetworking, it's a protocol stack that runs on top of IP to transport information from one computer to another, which is referred to as a TCP socket. We also have the flip side of that, the UDP. UDP is not connection-oriented. It is connectionless. It's actually what HTTP is actually kind of built off of in terms of the model. Protocol provides a mode for network communication whereby datagrams are sent over the network. The datagram socket is the abstraction used for that. Datagrams arrive. They have an arrival time. They have an order in which they is not guaranteed. And it's used whenever an information needs to be broadcast periodically when we don't have a constant connection. So a server would broadcast a message out to everybody. And then the clients that were available would pick it up and say, hey, look, here we are. And then when you send UDP packets back and forth, you open a socket, you send the datagram, you close the socket. You don't wait for confirmation to come back because you're not going to get any, essentially. So it's kind of a different type of application environment. It uses up less resources. Used actually implemented as a foundational concept to things like SMTP, which is Mail Transport Protocol. We have HTTP, actually runs off of a similar type of. Most people think, for some strange reason, that HTTP is connection oriented. You know, like when you run up and you go to a web browser, you type in www.google.com, you see Google. You don't have a connection with Google. You opened up a socket, you retrieved an HTML document, the main page for Google, you received it in your web browser and you closed the connection. You're not actually connected to the Google server when you're on that Google website. You're constantly sending and receiving by opening and sending and retrieving information back and forth. There's a request for information. And there's a receipt of the information, there's a request, and then you don't find this out until you start looking at web forms and stuff. And you go, oh, I have to send this. Then I have to wait to receive something. And then I have to send something again. There's no constant connection. It's not TCP. It's not like a TCP type of connection. When we connect our computers to the internet, and we have internet access, we're running TCP as a protocol. We have a constant connection for which the state of the connection can be monitored, and we have error checking, and we have a bunch of other stuff that we can do on it. HTTP is unreliable. No error checking, no constant connection. It's connectionless. In fact, you can run UDP through UDP through HTTP type of interfaces, where you bring up and you send something. The way that I can kind of describe this in parallels, UDP is you take a ball and you throw it across the street and you assume it makes it. Somebody picks it up on the other side, perhaps. Kind of like email. You know, when you write an email message and you send it out and you don't know if anyone ever got the email until they call you on the phone and go, why did you say that? That's so mean. Oh, you got my email. Versus when you're communicating with somebody on the phone, when you have a constant connection and you can send and receive simultaneously, and you can yell over somebody else, that's a constant connection. The TCP is constant, UDP is not constant. It's connection-oriented, it's connectionless. So here's one, you're getting a piece of information, you're sending and receiving, and we're wondering, why do we care if we're using TCP or UDP? UDP is efficient, it's fast, it's lower overhead, and it's better suited for some internet-related applications that you're developing. TCP, high overhead, it takes more bandwidth. You have acknowledgement, you have a receipt, you have a constant management of the connection for which you have a lot more traffic flowing. And it's better for some situations when you have constant state of the client. UDP is better when you have lots of clients and you don't really care who they are. They're just out there. Like such as exchanging files or something. So. Yep, broadcasting. UDP is great for broadcasting. Yeah. TCP is better for when you need to keep track of the clients. the client just can't go. Like if you're running a banking application and you're logged on to wellsfargo.com or something, do you really want to have to log in and check, provide your login information every time you go to a different screen or something? So the client's going to keep track, the server's going to keep track of all the clients, and then you log out. Gmail is a TCP related, is a constant connection type of interface, actually. It caches session information, actually. Which is interesting because it's running over UDP. It's running on a non-connection. When you go to Google, anything that's done through the web browser is actually not a constant connection. Yeah. But if you create a session and use the session concept, you've simulated a connection-oriented environment, because the session is facilitating all of the communication for you. Yeah, it's going to help you manage the connection in a non-constant connected environment. The session is what's doing it for you. So, if you have an interest in networking and network programming, here's some books you can go to. I don't know if the links are still working. I haven't looked at them in a while. But it's an entirely different breed of programming. It is definitely useful in today's today's market, useful skills to have. But if you're going to do that, you're going to be doing kind of some specialized stuff. If you're not using the socket interface, which most likely you're not going to use, you're going to be doing enterprise development, which is what you're going to be working with RMI, remote objects. You're going to be working with a JSP environment or servlet environments, and you're going to be doing more client server at a different type of programming interface than using sockets. And just to give you a brief kind of review of that or exposure to that, Java is great because in Java we can create an object and use the object over and over again. In networking, in computer networking, it's a client-server model. In the old days, we had common gateway interfaces, CGI stuff, where we could go to a server and every new client that connected invoked a new object and ran a program or did something. And each one, and going back to the sessions actually that I mentioned, each one of them has its own little session, its own little environment, it's keeping all of its information separate. What RMI did for us in terms of Java is it said on the server, let's just create one instance of every object. And we'll have a manager keep track of all these and they're called remote objects because they're not on the local computer. But on our computer, we can connect to a server, communicate with instances of objects that are created on the server, connection objects for databases, objects that run applications and utilities and programs that we might be interested in running. And it's efficient because we can have many different clients connect to the server and run one instance of the object on the server instead of each client creating their own instance of the object, which kind of revolutionized the client-server computing model because it made it efficient, made it so that one server can basically host objects and only one instance of one object is being used, host it out to millions of clients, and not have to deal with the overhead of all of the weight of all those clients that are connected. And when I mean weight, it means like each client doesn't get their own instance of the object, they're sharing it. And we have managers and we have security and we have a bunch of utilities that are built in the RMI engine that's on the server that's going to manage those remote objects. And when we invoke methods on those objects, it's all the same method. So in terms of processing speed, much faster, more efficient, better use of the resources on the server end, better management, better organization, better consistency among all of the different client usage. So then we have technologies like JDBC, which is sort of like ODBC in the old days, but it's used with Java to connect to databases. So instead of using you're not a remote object, instead you're connecting from from a Java program on your client machine, you're connecting to a server through a Java application, and you're connecting and you're creating a JDBC object for the connection. And the connection is managing all of the communication between the client and the server. And in this case, it's a database server. So there's a login, there's a query, and you have the sending of the results back, and you have all the communication that's facilitated by the JDBC that's on there. And we can take this a step further and say, well, let's look at the server environment in terms of JSP, which kind of runs very similar to ASP, but JSP again is more on the RMI model, using an Apache server or another type of server to serve up to make these objects available in a kind of a similar fashion, except for we have small little Java programs that run that perform tasks for us that we can integrate with an HTML output. Very similar to the way Perl was used initially, actually Python as well, but more of a Perl kind of thinking, where we had Perl modules that ran on a server and it fed Perl output that was translated to HTML that was sent to a web browser. So the good part about all these different technologies is there's a ton of things and they're all specialized for different things. If you wanted to create an HTTP web application interface, you're going the JSP route. If you've got a banking program that's running with remote objects on another computer, you're going the RMI route or something similar to that perhaps. JDBC, you're not working with an application, it's just private applications, just connecting to the database. You're going to take that technology. So you pick the kind of the technology that's going to work for the purpose, and there's a million of these things out there. And it's all written in Java. You learn Java once, and you apply it, the same language, to all of these other different applications, which is why, in my personal opinion, Java is the best language to learn, because you can reuse the skill. All you have to do is learn the technology. Learning the technology is like, learning how to use a program. You have to figure out how to configure it, figure out how to install it, and then create the components that you need to run. So, Android development, exactly the same way. You use the same Java skills you learned in this class to write Android apps that just run with a different API. So you make different instances of different objects, and you invoke methods on those objects in the same way that we've done networking, same way that we've done, GUI development, same way we've done regular old inheritance. So, all right, one more thing before we take a small lunch break. Let's take a look at this code here that we haven't looked at yet from the lecture we just looked at. Look at that, same two packages. Let me make it a little bigger so you can see it. Same two packages, java.net, java.io. The class is going to be a URL get. All this is going to do is create a URL object for us and run some methods on the object to get the pieces of the URL that we want, and then give us the file that we're getting at the end. So string get site, we got string builder, SB is equal to new string builder. It's just another specialized class stuff of IOStream, essentially, that's going to build a string that we can use for the object. URL connection, we're creating a connection object just like the lecture. We got our buffer reader in, we're creating. And we are just taking it, and I think, believe it or not, I think down here I've got the writer for the test site, Behecker, which is what's showing up in that screen. But this is essentially the same code that is in the lecture. That is, you can download this example, run through it, and kind of see how the connection object is created, and then see it's the same connection object, the same URL. You just apply it to different URLs. In this case, it's just taking and parsing from a text box the information and writing it to a stream, taking the stream, reading it, and then applying it to the connection object as the URL object. And then running the methods on the URL object to essentially, it's not doing anything at all. It's just reading in the byte stream. The byte stream is going to be whatever is at this particular location that we've gone to, which is why it's not displaying it in HTML. It's just displaying it, basically showing you the stream of information that's coming through, which is text, essentially. So if you wanted to, you could create another object, and I believe that Java has, and I haven't looked at it ever, but I believe it has an object for rich and HTML text extensions for which you can apply, to kind of create a more automated, you don't have to reinvent the wheel. You can actually get things to display in certain formats by changing the stream to different types of streams and stuff like that. So. And I'm not going to really go over the example because it's really nothing we have to do for this course. It is a bonus example if you want to play around with it to extend the behavior to work with the networking features. Questions about, we've finished all the assignments already. Questions about any of the assignments for the course? I don't have an example for number 5. So if you look at number 5, it's just taking and creating from an applet into an application or vice versa. It might be taking the application, turning it into an applet. Gives you the code, but it's not exactly an easy translation. So. Okay, so let's take a break then, and then we actually don't have very much left. We are going to end a little early today. We have, let's see what we have left here. We have one lecture left, lecture 10. We can take like a short break and then come back to the lecture on garbage collection, nesting classes, interfacing, about 20 slides. I don't want to rush through it and do it right now though, so I think it's probably better to take a break and then, unless you guys want me to do it that way. But I think you guys wanted a break. So. Okay, let's take another bio break. How long do you guys want? Huh? Come back at 1? Oh, that works for me. Come back at 1. Perfect. See you at 1. And then we'll finish it up. We'll be out here by 2:30 at the most.